We're Group 1 and we have pyruvate carboxylase.
Hi, I'm Ashley Nelson.
Hi, I'm Taylor Stolt.
Hi, I'm Avery Valls.
I'm Sarah Kenny.
Pyruvate carboxylase is an enzyme that catalyzes the irreversible carboxylation of pyruvate to form oxaloacetate. ATP is carboxylated to produce carbonic phosphoric anhydride, which in turn carboxylates a biotin cofactor that is covalently attached to a lysine residue of the BCCP domain. Carbonic phosphoric anhydride decomposes into CO2 and phosphate. This reaction requires acetyl-CoA as an allosteric activator binding to the PT domain. Next, CO2 is transferred to the acceptor molecule pyruvate to form oxaloacetate. The reaction proceeds via the removal of a proton from pyruvate to generate an enolate intermediate. The enolate intermediate then attacks CO2 released from the enzyme-linked biotin molecule, and oxaloacetate is released. The biotin molecule is protonated by the active site residue and released from the active site to be recarboxylated.
Mutations and pattern of inheritance. The gene pyruvate carboxylase is responsible for providing instructions to create the pyruvate carboxylase enzyme. The enzyme is active in the mitochondria, where it is involved in generating glucose, the body's main energy source. Mutations in the pyruvate carboxylase gene reduce the amount of pyruvate carboxylase in cells or disrupt the enzyme's activity. The absent or altered enzyme can no longer generate glucose, which impairs the body's ability to make energy in the mitochondria. The loss of the pyruvate carboxylase enzyme also allows the potentially toxic compounds lactic acid and ammonia to build up in the body, damaging organs and tissues. This condition is inherited in an autosomal recessive pattern, which means both parents must either carry the mutation or have the disease to pass it along to their children. If both parents are carriers, there's a 25% chance their child will have the disease.
Pyruvate carboxylase deficiency is a rare disorder that can cause developmental delay. All patients who develop symptoms in the first weeks of life are destined to develop lactic acidosis. PC is a biotin-dependent mitochondrial enzyme that plays a role in energy production in interplerotic pathways. It catalyzes the conversion of pyruvate to oxaloacetate, which is an essential substrate needed to produce citrate. This deficiency results in the failure of the citric acid cycle and of gluconeogenesis, thereby depriving the body of energy. The citric acid cycle derives energy from carbohydrates, while gluconeogenesis produces carbohydrate fuel for the body when carbohydrate intake is low. Loss of PC activity in the citric acid cycle lead to decreased glutamate production, which is important in the nervous system.
Symptoms and treatments. Researchers have identified 3 types of pyruvate carboxylase deficiency, distinguished by severity of signs and symptoms. Type A is the North American phenotype. It has moderately severe symptoms that include developmental delays and lactic acidosis. People with type A usually only survive until childhood. Type B is the French phenotype. It has life-threatening symptoms that include severe lactic acidosis, hyperammonemia, liver failure, and neurological problems. Infants usually only live to be a few months old. Type C is a milder phenotype. Symptoms include mild lactic acidosis and mild effects on the nervous system. People with type C usually have a normal life expectancy. Treatments are aimed at providing alternative fuels for the body and alternative ways to metabolize pyruvate. This includes supplementation of thiamine, lipoic acid, dichloroacetate, and citrate.